So this is problem number 8. A mass of 200 kilograms. So we have a mass in there which is equal to 200 kilograms. Is supported by a bar. So this is your bar and a pulley and a cable as shown. Determine, so letter A, the force exerted on the bar by the pin at point D, and the other one is the reaction at support A of the bar and the force exerted by link BC. So this is a link BC. So first, let's try to draw the free body diagram of the pulley. So we now have the FBD of the pulley. So this is your pulley. So we now have the FBD of the pulley. Okay, so you try to take note that the radius of the pulley is equal to 75 millimeter. So we have now the weight. This is your W. And then we have the cable. The tension in the cable. Let us consider this one as your T. The slope of the cable is 1:1. Hence, this one is now the radius, 75 mm. And this one in here is also the radius, which is 75 mm. It's 90, and that one is 90 degrees. This is your point D. So for your point D, we have the reaction of this pin at point D. So we have the vertical reaction. This is now your D vertical. And this one is now your D horizontal. This is your D horizontal. This one is your D vertical. So this is your point D. Now, so first, let us try to determine weight W. So your weight in here is now equal to the mass, which is equal to 2,200 kilograms. Multiply this one by 9.81 meter per second square. So the weight is now equal to 1962 kilogram meter per second square, or that one is in Newton. Now, let us try to take summation of moment about point D. So if you try to get summation of moment about point D is equal to 0. So I'm going to take counterclockwise moment, positive. So we have W, the moment arm is 75 mm. So this is 75, the radius of the pulley. This one is also equal to 75. A counterclockwise moment minus, okay, 75 minus T, multiply this one by the moment arm, 75 is equal to 0. So we have 1962 by 75 is equal to T, multiply this one by 75. Hence, the tension in the cable is equal to 1962 newtons. Now, let us try to take summation of forces horizontal is equal to 0 to the right forces positive. So, we have the horizontal component of T. So, I'm going to resolve at this point. So, this is now your T horizontal. And this one in here is now your T vertical. That is your T vertical. So, summation of moment, summation of forces horizontal is equal to 0 to the right forces positive. So, we have your T horizontal minus your D horizontal is equal to 0. So, your T horizontal is now equal to T multiply this one by 1 over the square root of 2. 1 over the square root of 2. So, your T horizontal is now equal to 1962 by 1 over the square root of 2. So, your T horizontal is 1962 1 over the square root of 2. So, your T horizontal is 1962 1 over the square root of 2 is now equal to DH. So, your DH in here is now equal to, we have 1387.344 Newton. So, we get a positive value, therefore the assumed direction is correct, and that is now going to the left. Next, summation of forces vertical is equal to 0, upward forces positive. So, we have your D vertical. And then we have next is minus your T vertical minus your W is equal to 0. So, your D vertical, so let's try to get first your T vertical. So, this is equal to T. You have the vertical slope all over the hypotenuse, 1 over the square root of 2. Hence, your T vertical is now equal to T, which is 1962 multiply this one by 1 over the square root of 2. So, your D vertical is now equal to, transpose this to the other side of the equation, so you have your TV, 1962 1 over the square root of 2. Okay, transpose that. So that is positive W, 1962. Hence, D vertical is now equal to 3349.344. Okay, so that is the value of the vertical component of the reaction at point D. So again, we get a positive value, therefore, this is going upward. Let us now determine the total reaction at point D. So the total reaction at point D, R, is now equal to the square root of so the total reaction at point D, which is now your RD, is now equal to the square root of the horizontal square, that 1387.344 square, plus D vertical square 3349.344 square. And therefore, the total reaction at point D is now equal to 3625.304. 3625.304 newtons. That is up to the left. Now, let's try to determine the angle that the total reaction at point D makes with the horizontal. So your theta with the horizontal is now equal to the arctangent of dV vertical, that is 3349.344 all over D horizontal, 1387.344. Hence, the angle that the total reaction at point D makes with the horizontal is now equal to 65.5 degrees. Now, let's try to draw now the free body diagram of. So we now have your FBD of bar ACD. Okay, this is 300 and up to the center of the pulley in here is 300 also. CD. Okay, you try to correct the dimensioning and the first figure. Okay, so this is A to C is 300, C to D is equal to 300. The radius is 75 millimeter. So that is 75 millimeter. So let's try to draw now the free body diagram of bar ACD. We have your bar ACD. So this is now the reactions at point A, or the reaction at point A. So we have a hinge support, so we have a vertical reaction and a horizontal reaction. This is your point A. So that is now your A horizontal, and this is now your A vertical. So we have, this is a link. You try to take note that the reaction of a link is a two-force member. So we have, this is equal to the reaction of the link, and this is now your link BC. And then the reaction at point D. So we have the reaction at point D. Now, in the free body diagram of the pulley, the reaction at point D. So the reaction at point D is going, your D vertical is going upward. Hence, in the bar, it will be going downward. So this is therefore your D vertical. Now, in the horizontal component of the reaction at point D is going to the left. Hence, this point, it will now go to the right. So this is now your point D. Since we are required to determine the reactions of the reaction at point D in bar ACD, then you try to take note that then your D vertical is now equal to 3349.344 newtons, and that is now going downward. And your D horizontal is equal to, that is 1387.344 newtons, and this go to the right. Hence, the reaction at point D as it acts upon bar ACD is now equal to, we have 3625.304 newtons. This is now down to the right. Okay, so that at theta H, which is equal to 65.5 degrees. Okay, so your D vertical is equal to 3349.344 newtons, and your D horizontal is equal to 1387.344 newtons. Now, let us try to take summation of moment about point A. Summation of moment about A is equal to 0. Let us try to consider counterclockwise moment positive. Okay, BC, so this is 300 mm. That is 300 mm. Your BC is going counterclockwise. So we have BC, the moment arm is 300 millimeter. D horizontal has no moment because it passes through point A. So your D vertical is going clockwise about point A. So minus D vertical, which is equal to 3349.344 newtons. The moment arm is 600 millimeter. And that one is equal to 0. So this is equal to. Hence, your BC is equal to 3349.344 by 600 all over 300, and that is equal to 6698.688 Newton. So that is the force exerted by length BC. Next, summation of moment about point D. Summation of moment about D is equal to 0. We have counterclockwise positive. Okay, so we have BC by 300. So that is BC, multiply this one by 300. So that is minus because that is going clockwise. And then we now have your AV is also going clockwise about point D. So minus A vertical, the moment arm is 600 millimeter. And that one is equal to 0. So we have 600 AV is now equal to, transpose this to the other side of the equation, so it will become positive. Negative. BC is 6698.688 88. Multiply this by 300. Hence, the value of AB is equal to negative 3349.344. 3349.344 newtons. Therefore, since we get a negative value, then the assumed direction of AB, which is going up, is not correct. So it should have to go down. Okay, so it should have to go down. So your AV is equal to 3349.344 newtons, and that is downward. Let's try to get now summation of forces horizontal is equal to 0 to the right forces positive. Minus AH plus DH, and the value of DH is 1387.344 newtons is equal to 0. So your AH is now equal to 1387.344 newtons. So we get a positive value, hence the direction is going to the right. So we get the assumed direction is going to the right. Hence, the total reaction at point A is now equal to the square root of AH horizontal, AH square, 1387.344 square plus A vertical square, 3349.344 square. So the total reaction at point A is now equal to, so that is equal to 3625.304. 3625.304. 25.304 newtons. And this is now down to the right. So it is down to the left. You get a positive value. So this is the correct direction. That is going to the left. And that is down to the left. So the assumed direction is correct because we get a positive value of A horizontal. Now, the angle that the total reaction at point A makes with the horizontal is now equal to the arc tangent of A vertical, 3349.344 all over 1387.344. So the angle it makes with the horizontal is equal to 67.5 degrees. So that is 67.5 degrees. So that is 67.5 degrees. Okay, so we have the next problem. So a beam is loaded and supported as shown. So this is your beam AB. So it is supported at A by a hinge and by a cable at point B. Determine the reactions at supports A and B. At supports A and B when M1. So your M1 is equal to 75 kilograms. And then your M sub 2 is equal to 225 kilograms. So that is your M sub 2. So first, let us try to draw the free body diagram of the pulley. So we have F, BD of the pulley. You try to draw now the free body diagram of the pulley. So this is again your, so we have now the pulley. So the center of the pulley. So I was going to consider now, this is now your weight 1. So this is W1. So that is M1. So we have W1. And let's try to consider that this one in here is now your T sub 1. I'm going to consider that one as T sub 1. So we have now the vertical component of this point. That is the vertical reaction of the support at the pulley. So we have the vertical reaction. And this one in here is now the horizontal reaction. So that is the horizontal reaction. So I was going to call point C as the center of the pulley. Now, let us try to consider now the radius of the pulley to be equal to R. So this is now the radius of the pulley. So this one in here is equal to, so that is the diameter, and therefore let's consider that the radius is now equal to R. So first, let us try to determine now the weight of the pulley. So that the weight of the pulley, the weight of this mass in here, which is equal to W1, is M1, 75 kilograms. Multiply this by 9.81 meter per second square. So your W1 is now equal to 735.75 kilogram meter per second square, or that one is in newtons. So let us try to take summation of moment about point C, or at the center of the pulley, is equal to 0. So I'm just going to get counterclockwise moment as positive. So we're getting moment. So we have W1 multiply this one by the radius, plus we now have your T1 multiply this one by the radius is equal to 0. Okay, R and R cancels out. So that's minus. If you transpose this to the other side of the equation, then R and R will cancel out. So that your T1 is now equal to W1. So T1 is now equal to 735.75 newtons. So that is the value of T1. Now, let us try to determine now the reactions, or the normal reaction between this weight and that of the beam AB. So if you try to get your FBD of mass M2. So let's try to draw now free body diagram of mass M2. So this is now your mass M2. Okay, so we have the center of the mass M2. So let's try to draw now the free body diagram. So we have now the weight W2. That is your W2. And then we have this one in here. The tension in here is equal to T1. So we have now your T1. So this is your T1. So that is now your T1. So we have your W2, you have your T1, and we now have the normal reaction between M2 and that of, the beam. So this is now the normal reaction, which is equal to R. Let us try to take, first let us try to determine W2. So what is W2 equal to? So your W2 is now equal to M2, that is 225 kilograms. Multiply this by 9.81 meter per second square. So your W2 is now equal to 2207.25 kilogram meter per second square, or that is in Newton. Let's try to get now summation of forces vertical is equal to 0. We have upward forces positive. So this is your R plus T1 minus W2 is equal to 0. So your R plus your T1 is 735.75 minus your W2 is 2207.25. So that is equal to 0. So the value of R is now equal to 1471.5 newtons. 1471.5 newtons. This is 1471.5 newtons. Ano dito nakakwa? Okay, so we now have to, let's draw the free body diagram of beam AB. So this is now your beam AB. So this is your A, and this is now your point B. So we have now the reaction at point A. So we have, that is a hinge again. So we have vertical and horizontal reaction. So this is your A horizontal. This is now your A vertical. So we now have the reaction between M2 and that of the beam. So this going upward in the weight M2, therefore it will go downward on beam AB. So this is now your reaction, which is equal to R. This is now the tension in the cable at point B. So this is the tension in the cable at point B. So let's try to consider that one as T, now such that the slope of the cable is 1 horizontal to 2 vertical. Now, this is equal to 520 millimeter, and this is 4 180 millimeter. Let us try to resolve the components. Let us try to resolve the component of the tension in the cable into horizontal and vertical component. This is now your T horizontal. And this one is now your T vertical. Now, let's try to get your T horizontal is now equal to T, the horizontal slope, hence this is equal to the square root of 5. 2 square plus 1 square. So that is the square root of 5. Multiply this one by the horizontal slope is 1 over the square root of 5. And your T vertical is equal to T. We have the vertical slope, which is equal to 2 over the hypotenuse of the slope triangle. That is the square root of 5. Now, let us try to get moment about point A. So if you try to take summation of moment about A is equal to 0. So we have counterclockwise moment positive. Your TH has no moment about point A because it passes through the moment center A. So your T vertical is going counterclockwise about point A. That is your T vertical. So the moment arm is 520 plus 480, or that is equal to 1,000 millimeter. Now your R is going clockwise about point A. So that is minus R. The moment arm is 520 millimeter. And that one is equal to 0. Hence, your 1,000 T vertical is equal to R, and the value of R is 1471.5 newtons by 520. So your T vertical is now equal to, now your T vertical therefore is equal to 765.18 newtons. 765.18 newtons. Or from this equation, T vertical. So let's try to determine now your T. So your T vertical is equal to 765.18 newtons is equal to T, multiply this by 2 over the square root of 5. Hence, the tension in the cable at point B is equal to 855.497 newtons. Next, let us try to take summation of forces vertical. So summation of forces. Okay, so I'm just going to get your TH in here. So the value of your T horizontal is now your T. So that is T horizontal. T is 855.497 by 1 over the square root of 5. So your T horizontal is now equal to 382.59 newtons. So it's 382.59 newtons. Okay, so next, Ni in-erase ko met the free body diagram. Okay, so next, from the same free body diagram, so from this free body diagram, so I'm going to read through again the free body diagram. Okay, so let's try to continue. I redraw the free body diagram of beam A, B. So, your T vertical is 765.18. Your T horizontal is 382.59. And the reaction between M2 and that of the beam R is equal to 1471.5 newtons. Let us try to determine now the reaction at point A. Summation of forces vertical is equal to 0, upward forces positive. So we have your A vertical, and then we have minus R, and the value of R is 1471.5 plus T vertical, and the value of T vertical is 765.18, and that one is equal to 0. Hence, A vertical is now equal to 706.32 newtons. 706.32 newtons. We get a positive value, hence the assumed direction is correct, and therefore that is going up. Summation of forces horizontal is horizontal is equal to 0, to the right forces positive. So your A horizontal, okay, so plus TH, and the value of TH is 382.59 newtons. And that one is equal to 0. So your A horizontal is equal to negative 382.59 newtons. So we get a negative value of AH, hence the assumed direction, which is going to the right, is wrong. Then your A horizontal is equal to 382.59 newtons. This will go to the left. That will go to the left. Okay, so therefore, the total reaction at point A is equal to the square root of A horizontal plus square plus A vertical square. So we are, okay, so let us try to get now the total reaction at point A. So this is therefore the square root of A horizontal square plus A vertical square, and this one is now equal to, this is equal to 803.28 newtons. That is up to the left. So the angle that the total reaction at point A makes with the horizontal is now equal to the arc tangent of A vertical, 706.32, all over A horizontal, 382.59. Okay, so we now have this is equal to 61.6 degrees. So that is the angle that the total reaction at point A makes with the horizontal.